Oracle Shared Server. In this nugget, we're going to talk about shared server concepts, which is a feature that you can turn on in your database to maximize the performance of the servers that actually get the work done in your database. Do you know anyone that has a personal chef? I always thought it would be a neat thing to have a personal chef, get up in the morning, have this chef make me breakfast, and then I come home for lunch. The chef makes me a nice grilled cheese sandwich, and whenever I want my food, the food's there. And this one chef is dedicated to me and only me. Great concept. However, unfortunately, I can't afford it. And then I got to thinking, why can't I afford a personal chef? Well, let's see. This chef needs to make a living, and most of the time, he or she is just idle doing nothing, just sitting around. And quite honestly, I can't afford to just pay for someone to sit around most of the time and just feed me once in a while. So I figured the next best thing is to go out to eat, go to a restaurant. Well, why can I afford a restaurant but not a personal chef? Well, the reason why is a restaurant's a lot more efficient. They have a few chefs that are in the kitchen dedicated to making food, and they have some wait staff, some dispatchers communicating between us and the kitchen, and they're just maximizing the throughput. I mean, usually when I go to a restaurant, the waiter or waitress isn't just dedicated to me. This person is usually serving several other tables at the same time. And then when they take my order, they'll, just send the order off to the kitchen and it goes in a queue and eventually I get my food back. The dispatcher brings it back to me. So I'm interchangeably using the words waitress and dispatcher, but that's essentially what the waiter or waitress is, right? They're just taking the order, putting it on the queue, stuff comes out of the kitchen, and it comes back to me through the waiter. Well, we have the same kind of concept with shared server architecture. If you're in a dedicated server mode, then every user is going to have a dedicated server process used to go fetch information, which is fine in a really small environment. Well, if you've only got, 100 users on a system, then using dedicated mode is just fine. If you've got several hundred users on a system, then you probably want to use the shared server option. The concept behind shared server is that you might have thousands of users, and those thousands of users are going to be utilizing just a pool of server processes. So we'll talk more in a moment about the differences between dedicated versus shared server mode. We'll talk more about dispatchers. Think of that as the communicator between the user and the queues. And we'll talk about the different components in our shared server architecture. We have our dispatchers, we have server processes, and we have request and response queues. And then I'll show you how to configure your parameters to turn on the shared server option mode. And then we'll also configure our memory within the database to maximize the throughput of our shared server. I'll also show you how to force dedicated server mode for a client tapping into your database. So you can have a database that's serving many users in the shared server mode and then have a few dedicated servers for just a handful of clients. And then I'll show you ways of monitoring your shared servers to see what's going on behind the scenes. Here's a nice little diagram showing the shared server architecture. Now down here, these little U's in circles, those are user processes. A user processor is something like, well, maybe if you have a SQL Plus session going on, or if you're using the tool called FreeToad, or if you've got a Java program that's tapping into the database. I mean, a user process is any process that is tapping into the database. This black U here is special because it's talking directly to a server process. So this is what we call a dedicated server environment. Now, a server process is just a process that communicates either with the database buffer or it grabs information from the actual database. So it's the process that's getting all the work done. So once again, in a dedicated server scenario, we've got a user process talking directly to a server process. Now, if we had every single user on our database doing this, and let's assume that we had, 5,000 users, then each one of those users would have its own server process, which could be a really bad thing. We could spawn too many processes and run out of memory. Did you know that in a dedicated server environment, this server process is usually sitting idle about 70% of the time? For example, if you're sitting in front of your SQL Plus screen and you're thinking of the command to type in, you're pretty much sitting there, maybe doing research, maybe, I don't know, playing solitaire, who knows what you're doing, but you're not issuing SQL queries the whole time. So the bottom line is that a shared server environment, for the most part, is going to be more efficient, especially if you have quite a few users on your system. Now, let's take a look at our shared server architecture. We have all these green U's here. Let's imagine we have 5,000 of them. So instead of talking directly to server processes up here, they actually talk to what we call dispatchers. Think of these as the waiters. As soon as the user orders something to happen, well, the next available dispatcher takes that request, places it onto what we call a request queue, and then the next available server process will pick it up, do its thing, access the database or access the buffer, and then take the result and place it on the response queue. So think of these server processes as being the chefs back in the kitchen at a restaurant. You know, you really don't know who it is that's cooking up your food, and I couldn't care less as long as they're not spitting in my food. I don't care who's making it. Just get me my food. However, I do have a dispatcher that is going to be dedicated to me for, at least for that one little request. Now notice here that there's one request queue, but there's multiple response queues. That's because each dispatcher has its own queue, and the dispatcher knows who to give the data back to. Just like when you're in a restaurant, you usually have one waiter that's sticking by you. Then the response goes back to the appropriate dispatcher, and then that result set gets back to the user. So you only need a handful of dispatchers, and you need a handful of server processes. You've got a request queue and a response queue. And you can configure all of these different parameters. You can configure how many dispatchers there will be when you first start up your database. You can configure the max number of dispatchers, as well as the initial and max number of server processes. You can also specify how large that request queue can get. But when you're configuring your database for shared server architecture, you do need to be really careful, because if you do something stupid, like say, hey, I want the max number of server processes to be 1, well, then you can really clog up the system. Imagine that you're at a restaurant and you only have one chef cooking food up for, 1,000 people in the restaurant. There's only so fast a chef can go, and there's only so fast a server process can go. So you will need to perform some math. You'll need to figure out, well, what's the max number of users I'm going to have at a given time? And you need to configure things such as memory structures so you don't run out of memory. Something important to remember about user processes is that Oracle needs to somehow remember the information about a session. Okay, so that information is stored in what we call the user global area, or the UGA. Now, if you're in a dedicated server environment where the user process is talking directly to its own server process, then that UGA will actually be stored in the server processes PGA, or program global area. Okay, so it will be stored along with the server process, essentially. Well, in a shared server architecture, that's not the case. It actually is going to be stored in what we call a virtual circuit. And it's just a piece of memory that's stored in the SGA. It's still in the user global area, but the UGA is no longer bound to a specific server process. It's actually in the SGA generally, and it's accessible to all of these different server processes. And this concept is going to make a difference when we start calculating how much memory we need. So once again, a virtual circuit is just a shared piece of memory that's in the SGA, and it's going to be in with the request queue. Another important point to remember is that these dispatchers are not going to be dedicated to the same user process over each query. For example, if I issue a SQL statement, my user process is going to grab the first available dispatcher process. And then the second time when I issue a query, it might use a different dispatcher process. So this would be kind of like if you're in a restaurant and you have a team of servers just taking care of everyone. It's like, hey, whoever needs help, just go take care of them. Let's talk about the parameters we can configure for our shared server environment. Out of all these different parameters here, we've got dispatchers, max dispatchers, shared servers, max shared servers, and circuits. Really the only one in 10G that's required to configure your shared server environment is this one, shared servers. And all that says is this is the number of shared servers that your database is going to start up with. This is actually a dynamic parameter, so you can alter this without bouncing the database. So as soon as you set this to a non-zero value, you're now using the shared server environment. You can also configure the max number of shared servers. So here I set my shared servers to 6 and my max shared servers to 20. Okay, so we also have our dispatchers. Remember, the dispatchers are like our waiters. They're simply taking our requests in a first come, first served basis and placing those requests onto the request queue. So we can have several entries in our dispatchers parameter. For example, here, you'll see that I have one dispatcher here using the TCP protocol, and I set the number of dispatchers to be 5 and the number of connections to be 1,000. Now let's talk about what these different values here mean. For the connections, all we're doing is specifying how many connections a dispatcher can have. The max number of connections is going to be operating system specific. For example, on Solaris, the max number of connections per dispatcher is going to be 1,024. So you'll have to look up the documentation for your OS. This dispatchers here is just telling us how many dispatchers to initially start up. And here, of course, is the protocol. Pool equals both means that we're turning on connection pooling, both incoming and outgoing. So you have more throughput for the sessions. Now, if you're using connection pooling, then there's going to be a timeout value, and that's going to be by default 1 second. Now, if you want to set the tick to something else, Oracle actually recommends setting ticks to be either 3 or 4 seconds, then you can override that right in here. So basically, connection pooling is simply saying that idle sessions that are sitting there doing nothing are not going to hog a connection. So here we have a second entry in our dispatchers, and this is for the TCPS protocol. And so for TCPS, here we're saying, okay, we'll start off with 2 dispatchers, and we'll limit our number of connections per dispatcher to be 800, because we might have a little more activity, perhaps, per dispatcher. So how do you actually calculate the number of initial dispatchers you want? Well, what you should do is find out the maximum number of concurrent sessions you think you're going to have. And you might, figure something out initially and then tune it later. So let's say that you assume you'll have a maximum of 5,500 concurrent sessions, and you've got 1,000 connections per dispatcher. So you do the math, and then you just round that up to the nearest integer. So there we would get dispatchers equals 6. Okay, so you can also set the max number of dispatchers. Let's talk about circuits. Do you remember what a circuit is? It's a shared piece of memory that's stored in the SGA, and it's basically going to be in the request queue. And the value for circuits is actually going to default to the sessions parameter, which just specifies the max number of sessions we can have at a time. The only time you want to override that value is if you think you're going to be using a lot of database links. Every time you use a database link, it's going to use an extra circuit. So, let's say you think you'll be using database links heavily, go ahead and make circuits be something between the sessions parameter and double the sessions parameter. You can set your dispatchers parameter by doing an alter system statement. So we'll say alter system set dispatchers equals, and we'll go ahead and set it to what it is right up here. So for the TCP protocol, we'll have 5 initial dispatchers and 1,000 connections per dispatcher. And we're also going to use connection pooling for that protocol. Then for our TCPS protocol, we'll have 2 initial dispatchers with 800 connections each. Now it's when we set up our client configuration that we can decide whether we want to use TCP or TCPS. Okay, so let's say set dispatchers equals, and we're actually setting two values inside the dispatcher. So we'll put each of those two values inside of single quotes. So here we'll say, okay, protocol, and this is not case sensitive, equals TCP. Dispatchers equals 5. Connections equals 1,000. Pool equals both. That's both incoming and outgoing communication. And then ticks equals 3. So the timeout is 3 seconds for the connection pooling. Okay, so that one is set, so we terminate it with a quote, then just do another comma, and then set the second one. Protocol equals TCPS. Dispatchers equals 2. And connections equals 800. Okay, so our system is altered. Now let's do a show parameter dispatchers just to prove that we have set this. One tricky thing to keep in mind is that when you're setting your dispatchers, if the initial value is set to null, you will not be able to dynamically alter it with the alter system. Even if you say scope equals SP file, you won't be able to do it. What you'll have to do is create the P file from your SP file. We covered that in a previous nugget. And then edit that parameter file and set your dispatchers in there, and then recreate the SP file from the P file. Then you have to bounce the database. Whew, it's a lot of work. Our max dispatchers is already set to 20, so that's fine. Let's see what we want to set our shared servers to. Let's say show parameter shared servers. And we have a value of 200 for the max shared servers, and we have a value of 6 for the shared servers. Well, let's go ahead and stick with those values. And I'm just going to let my circuits default to its default value because I'm not using database links heavily in my database. In order for us to properly configure our database for shared server architecture, we do need to set the large pool size. Okay, the large pool size is going to account for the user global area for all your sessions, plus any cursor overhead. So anytime you open up a SQL statement or you have a PL SQL block that's using cursors, there's going to be a cursor overhead of about 250 bytes per cursor per session. And then the sum of this plus 10%, just to add a little buffer, that's going to be our large pool size. So we can find out information about the various sessions on our system by looking at a dynamic view called $session_stat. You'll see that it gives us information about the session SID, the statistic number, and the value. Now, unfortunately, it doesn't say anything about the statistic name, so we will have to do a join on another view called $stat_name. And there we can do a join on the statistic number, and there's the name. So here I'm going to sum up, I'm going to get a count of the number of sessions. So I'll say session count. And I also want to grab just, let's say, the first 30 characters of the name of my statistic. So I'll say substring of b.name 1, 30, and we'll just call that name. And then let's get the average value of our statistic from $session_stat. We'll give that an alias of A, and $stat_name of B. Now let's do a join clause where A.statistic number equals B.statistic number. We only care about the ones that have UGA in the name. So we can also say and lower B.name like UGA. The count and the average are aggregate functions, so we will have to do a group by B.name. And there we go. We found out information about the average value of our session UGA memory. And the session UGA memory max, think of that as kind of like a high water mark. That's the highest it's been since the database has been up. Okay, so we take about the average of those numbers and multiply it by the session count number. and that's going to be our UGA. So let's just do the math here in a select statement. We'll say select, let's say about 350 just to be generous, 350,000 times 15 from dual, and that gives us about 5.25 million bytes. Okay, so let's go ahead and record our UGA up here. Remember, it was 5.25 million bytes. Now we want to calculate our cursor overhead. Now, the way we find out information about our cursors is by looking at a data dictionary view called $$ open cursor. Let's do a describe on that. And we've got the SID, which is the session ID, and we're really not concerned with the SQL ID or the SQL text or any of that, but we are interested in the meta information. So $$ open cursor contains information about all the open cursors per session. So we can use some aggregate functions on here. For example, we can say select count. We'll call this sessions. We also want to find the average number of cursors per session. So we'll say average count. And we can also find the high water mark of our cursor for our session. So when we say max count star, max cursor, what we're finding out here with max count is finding the max number of cursors for all of your sessions. Okay, so from $$ open cursor, and then we'll do a group by clause, so group by SID. Okay, so here we're finding out that there's 14 sessions. Now earlier it said that there were 15 sessions, and remember we're on a live database and there can be, you know, varying activity, so it's not going to stay static. Now the average session has a little over 11 cursors open. 62 is the highest number of cursors that a given session has had, and this is since the database has been up and running. Now if you're on a larger database, you can have numbers much higher than this. Okay, so what I like to do is find a number that's in between these two numbers, and I like to be a little generous. I lean towards the max size. So I'll say 45. So I can say select 45 times, and then the number of sessions, so 14. Now there's an overhead of about 250 bytes per cursor, so we'll say times 250 from dual. And we get about 157,000 bytes. So that's our overhead. So we'll plug this number into here. We'll round it up. We'll just say 160,000. Doesn't hurt. So now we want to find the 10% overhead. So that 10% is 10% of the sum of these two numbers. So we can say select and plug in these numbers. Okay, times 1.1 from dual, and this is going to be our grand total. Okay, so that's almost 6 million bytes. So we go ahead and plug that number in here, and that is our grand total. So this is what our large pool size should be. Okay, so now all I need to do is simply say alter system, set large pool size equals 6 million. From your client's end, you can configure your connection to use either a dedicated server process or a shared server process. You'd want to use a dedicated server process if you have a long-running query or if you've got some kind of action that's intensive, like if you're using RMAN to, do a complete backup. Well, you want a dedicated process for that. Okay, so here in my tnsnames.ora file, I set up two services. I called one ORCL and the other test1. So you would configure this on your client's machine. And really the only difference between these two services is the server mode. Here I said server equals shared, and down here server equals dedicated. Now if I omit this clause, server equals whatever, then it defaults to shared server mode if you have it configured on your database. And just to test this, we can do a TNS ping on our ORCL, and you'll see that this will be successful. Okay, good. And then let's do another TNS ping on test 1. Okay, very good. It's also in this file where you could configure whether you want to use TCP or TCPS for your protocol. I left it as TCP for both of these. You might find that your shared servers aren't performing as well as you'd like them to. And so what you can do is do a little bit of monitoring. For example, we have some $V views that can help us peek into what's really going on. For example, $V shared server tells us what's going on with the actual shared servers. So all of our shared servers have a name and a status, and we can also find out in hundredths of a second how much time they've been idle and how much time they've been busy. So if the total busy time is much larger than the idle time, then you probably want to increase your number of shared servers. For example, here I'm going to say select name, idle, busy from $V shared server. Now, I don't have much activity on my database, so we'll see that there's not much busyness at all. We're pretty much idle. See the names of my shared servers? They have S000, 01, and so on. So they're just numerically named. If you're on a Unix or a Linux system, you can actually see these server processes by issuing the ps-ef command. If you're on Windows, then all of this is bundled up into one process, and these are each different threads within the process. Likewise, you can find out information about your dispatcher activity. For example, you can find out the name of your dispatcher and, the busy and idle time. Once again, these are in hundredths of a second since the database has been up or since we moved to shared server architecture. If you find that your dispatchers are too busy, then go ahead and increase the number of initial dispatchers, and you might also want to increase the max number of dispatchers. Now you can find out information about what is in your request and response queues by querying $queue. So remember, the request queue is a common queue that all the dispatchers use. Each dispatcher has its own response queue. So let's go ahead and query this. We'll find the address of the queue, the type, it's either going to be common or a dispatcher. Wait is the total time in hundredths of a second that this element in a queue has been waiting. And then total queue is the number of elements total in that queue. So if you were to take wait divided by total queue, you can find out the average waiting time of an element in that queue. Okay, so you'll see here that we have one common request queue and we have 7 dispatcher queues. Now there's not much wait activity on my machine, but you'll see different results in a real live production database. Let's review what we've learned. We first of all talked about our shared server concepts. And remember this diagram? We can have hundreds or even thousands of user processes. Remember, a user process is just any kind of process. It can be like SQL+, it can be a Java program, a Perl program, anything that's tapping into our database. So those user processes are going to be talking to a dispatcher, which simply just takes our requests, places it onto the request queue, and then the available shared servers pick up the requests from that queue. It might either tap into the actual database or grab data from the buffer cache, and then place the response on the response queue. And each of these dispatchers has its own response queue, so it knows who to take the response back to. We talked about several parameters that we can set. The only required parameter was the shared server. You can also configure max shared servers. It's a good idea to set your dispatchers, otherwise it defaults to one dispatcher. You can also set your max dispatchers, as well as the circuits parameter. That's only if you're going to be using database links heavily. Then you also need to make sure you configure enough memory in your SGA for all those shared servers. Remember, the large pool size is that parameter that we want to set. And that was the sum of the UGA plus any cursor overhead plus 10%. From your client's perspective, you can force dedicated server mode by modifying your tnsnames.aura file and specifying that the server equals dedicated. And it's also there where you can say you want to use TCP/S protocol instead of TCP. And then the last thing we talked about was monitoring our shared servers. Remember we had $V shared server as well as $V dispatcher and $V queue. So you can find out information such as the idle and busy time of those components. Well, I hope this has been informative for you, and I'd like to thank you for viewing.